Ever wondered if space has a substance, a medium that carries light across the universe? Welcome to the concept of the luminiferous ether. It's a fascinating hypothesis, a relic from the annals of scientific history. This ether was once thought to be the invisible fabric of the cosmos, the carrier of light waves across the vast expanse of the universe. It's an idea that has sparked countless debates and revolutions in scientific thought. But what exactly is this ether we're talking about? Let's dive in. Imagine you're a fish in an ocean. The water around you is the medium that allows you to move and exist. Similarly, the luminiferous ether was once believed to be the cosmic ocean through which light waves move. Let's delve into this concept a bit more. Picture the universe as a vast, boundless ocean. This ocean, instead of being filled with water, was thought to be filled with a mysterious substance known as the ether. Just as fish move through water, scientists of yore postulated that light waves travel through this ether, making it the universal medium of propagation for all things luminous. This concept of a cosmic ocean of ether may seem a bit outlandish to us now, but it was a cornerstone of scientific understanding in the 19th century. Scientists were grappling with the nature of light. They observed that sound waves need a medium like air or water to travel. In a similar vein, they hypothesized that light, too, must have a medium to propagate, leading them to postulate the existence of this all-pervasive ether. The ether was imagined to be an invisible, undetectable fabric that permeated all of space. It was thought to be motionless and absolute, offering no resistance to the bodies moving through it, yet allowing light waves to ripple across its expanse. It was the perfect solution to the puzzle of how light could travel through the seemingly empty void of space. Yet this concept was not without its critics. Some pointed out that if the ether really filled all of space, why couldn't we detect it? Why didn't it slow down the planets in their orbits? These were valid questions that led to a great deal of scientific debate and inquiry, propelling our understanding of the universe forward. So, were scientists right? Is there really a cosmic ocean that light waves swim through? The answer to this question would revolutionize our understanding of the universe and forever change the way we perceive space and time. But that, dear listener, is a story for another time. If ether is like an ocean, then we should feel an ether wind as Earth moves through this cosmic ocean, right? This question brings us to the concept of the ether wind. The idea is simple. If the ether is a stationary medium filling the universe, and the Earth is moving through it, then we should experience a wind-like effect. This ether wind would be felt as a slight shift in the speed of light, depending on the direction it's traveling, similar to how a breeze affects the flight of a bird. The ether wind became the subject of an ingenious experiment conducted in the late 19th century. The experiment was carried out by two American scientists, Albert Michelson and Edward Morley. Their goal? To detect the subtle shift in the speed of light caused by the supposed ether wind. Michelson and Morley designed a precise instrument, known as an interferometer, capable of measuring the speed of light with extraordinary accuracy. The idea was to compare the speed of light beams traveling in different directions, one parallel to the Earth's motion, the other perpendicular. If the ether wind existed, the speed of these two light beams would be slightly different. Yet when they conducted their experiment, Michelson and Morley found no difference in the speed of light, regardless of the direction it was traveling. Their results were consistent, precise, and to many, shocking. There was no evidence of an ether wind. This finding was a serious blow to the ether theory. If the Earth was indeed moving through a cosmic ocean of ether, then where was the ether wind? The absence of this wind suggested that either the ether didn't exist, or our understanding of it was fundamentally flawed. The absence of the ether wind was a compelling argument against the existence of ether, but the story doesn't end here. Our journey into the enigma of the ether is far from over, so stay with us as we delve deeper into this cosmic mystery in the next scene. Enter Albert Einstein. His theory of relativity turned the concept of ether on its head. Einstein, a name synonymous with genius, brought forth a revolutionary idea that challenged centuries of scientific understanding. It was the dawn of the 20th century, a time ripe for a paradigm shift, and Einstein was at the helm. Einstein's theory of relativity proposed that the laws of physics are the same everywhere, regardless of one's perspective or motion. This means that light, contrary to what was believed, does not require any medium like ether to travel. It moves at a constant speed, approximately 300,000 kilometers per second, in all frames of reference. It was a radical idea, as it went against the popular belief that light, like sound, needed a medium to propagate. In the world according to Einstein, there was no need for ether. His equations worked perfectly well without it. The ether, which was once considered the very fabric of the universe, was seemingly rendered obsolete. For a moment it seemed like the ether, this cosmic ocean that was believed to permeate all of space, had been drained dry by the sharp intellect of Einstein. However, the story doesn't end here. Just when the scientific community was getting comfortable with a universe devoid of ether, Einstein threw a curveball. In his general theory of relativity, he reintroduced a new kind of ether. Not an ether of particles, but an ether of space-time geometry. This was not the ether that had been cast aside, but a modern, refined ether that was integral to the shape and curvature of the universe. Einstein's revolutionary theory seemed to discard the ether, but he later reintroduced a new kind of ether in his general theory of relativity. The tale of the ether is a tale of science itself, always evolving, always questioning, and forever pushing the boundaries of our understanding. Einstein gave ether a new life, but not as a medium for light. Instead, it became associated with the fabric of space-time itself. This statement may seem perplexing, given that Einstein's theory of relativity had originally dethroned the ether concept. But stay with me here. It's about to get interesting. In his later years, Einstein referred to ether in the context of general relativity. He argued that while there was no ether in the sense of a static, absolute framework, space-time itself could be viewed as a form of ether. It was a kind of ether that was dynamic and intertwined with matter and energy. What Einstein was suggesting is that just as fish may not notice the water they swim in, we might not notice the ether-like qualities of space-time because we're immersed in it. Fast forward to the 21st century, and the ether concept has evolved even further. Modern physics has introduced us to the idea of quantum field theory. This theory suggests that all particles are simply excitations or ripples in their respective fields that permeate all of space. The Higgs field, for instance, gives particles their mass, while the electromagnetic field is responsible for light. In a sense, these quantum fields are the ether's modern descendants. They are unseen, yet they shape the very nature of our reality. So, what's the takeaway from all this? It's that the concept of ether, once thought to be obsolete, has made a surprising comeback. It's not the same ether we imagined in the 19th century, of course. It's not a static, all-pervading medium for light, but it is a concept that helps us make sense of the fabric of the universe, from the curvature of space-time to the fundamental properties of particles. The ether, once discarded, found a new identity in the complex world of modern physics. So, next time you marvel at a beam of light or the mass of an object, remember the ether. It may not be what you thought it was, but it's more fascinating than you could ever have imagined. So, where does this leave the luminiferous ether? Is it a relic of the past or an overlooked truth? As we navigate the cosmic ocean of our understanding, it's clear that the concept of ether has had quite the journey. From its early days of being perceived as the invisible, omnipresent medium for light waves, to its dismissal with Einstein's revolutionary theory of relativity, the ether's tale is one of intrigue. This once revered concept, believed to be the fabric of the cosmos, was dismissed as an unnecessary hypothesis. The ether was banished from the realm of scientific reality, deemed an artifact of an older, simpler time in physics. But like a phoenix rising from the ashes, the ether has made a surprising comeback, finding potential reinterpretation in modern physics. Today's quantum field theory, for instance, draws parallels with the ether. It postulates that space is filled with virtual particles that constantly pop into and out of existence. It's a far cry from the static ether of the 19th century, but it's an ether-like concept nonetheless. But here's the most surprising aspect. Even though the ether was dismissed, it helped to shape modern physics. It forced scientists to question, to explore, to push the boundaries of what was known. The story of ether serves as a reminder that in the quest for understanding the universe, no idea, no matter how seemingly outdated, is ever truly off the table.